Today I'm going to take a look inside of this broken LED light bulb. This is a Utilitech 40 watt equivalent LED light bulb, which uses 5.5 watts at 120 volts. It's rated for 450 lumens output and is not for use with dimmers, but suitable for damp locations. This light bulb was installed in one of those outdoor light fixtures, so being used outside might have shortened its life a bit. To show you what happens, I'm going to plug it into a lamp holder and turn it on, and turn off the light and turn it on. It lights up very, very dimly and even flickers quite a bit, which is not what an LED light bulb is supposed to do. So now I'm going to take a look inside of this bulb. And these things are glued together, so I'm going to need to use force to open this. There's a gap right here. This thing is glued together. Oh, okay. Phew. Now I got the cover off. There are 9 LEDs. Let's see if it works with the cover off. This is a super dangerous idea because the high voltage is exposed. But let's plug it in. Interesting. Each LED is made of 3 tiny LEDs. And the last one... Oh, what? I fixed it just by pressing that last broken LED? What? What? How did I fix it? The last LED, this LED is broken internally. And now it's... Holy... Well, that last LED melted. Wow. There's no way of getting this back together, so I guess I'll take a look further in the lamp. And how do I get it out? Even the PCB is glued in. They did do something right. There's some large copper areas around LEDs to help dissipate the heated LEDs into the housing. Now I'm going to try breaking apart the housing of the LED bulb to access the other circuit board, the power supply. Now come out. Oh, okay, there we go. Got the LED board out. We'll cut the wire. And now there's a power supply inside of there. Try and pull it out. I removed the power supply module from it. This is interesting. It just has 2 capacitors, 2 inductors, and a small transistor on the front. And on the back, there's a full bridge rectifier, some resistors, capacitors, and a diode. And also, the input even has a fuse under this heat shrink, which is interesting. That thing actually wasn't a fuse. It actually is a 2.2 ohm resistor. Interesting. So they're using a 2.2 ohm resistor as a fuse. And another good thing is the capacitors are rated for 105 degrees Celsius, so they can handle the heat inside of the lamp housing. Another thing to check, is the housing actually made of metal? Or is it just plastic? What? The housing is only made of plastic? That's very disappointing. That could be another reason why the LED failed, is the plastic can't dissipate heat as well as a metal heatsink. I just found the light bulb on Lowe's website, and it is the exact same bulb I'm looking at in the video, and it only provides a 5,000 hour life. So the design really isn't surprising considering what its rated lifespan is. And it seems to have an updated model, which uses 6.3 watts instead of 5.5 watts like the bulb in the video, but has a 15,000 hour life. And also this bulb is out of stock, so I can't get it to take a look inside of it. After looking at the pictures I took, the transistor on this little board isn't a transistor. It actually is a non-isolated constant current LED driver. And it is a buck converter which uses the inductor to step down the voltage. It even includes thermal regulation function. And if we go to the page where they mention the thermal regulation function, it says, when the system is over temperature, the output current is gradually reduced. The output power and thermal dissipation are also reduced. The system temperature is regulated, and the system reliability is improved. The thermal regulation temperature is set to 140 degrees Celsius internally. Wow. That is way too hot for these LEDs, I think. And this controller chip is mounted on a separate board from the LEDs, so it can't sense the LED temperatures really. But I'm going to try to make a schematic of this horrible controller thing. Well, I made a schematic of the circuit, and it's kind of interesting. But what's even more interesting is it's almost an identical copy of the typical application schematic in this datasheet, except for the addition of some extra components here and 2 current sense resistors instead of just 1 in the application schematic. But let's take a look at the schematic of the board. The power comes in through a 2.2 ohm resistor that acts like a fuse and could limit inrush current, and a 3 millihenry inductor with a 5.1 kilo ohm resistor across it. This could help reduce any electromagnetic interference. Then it goes through the full bridge rectifier here, and then the 4.7 microfarad 200 volt capacitor. The negative line goes through this capacitor of unknown value to the left pin of the control chip. The negative line also directly goes through 9.1 ohm and 10.5 ohm resistor to the middle pin of the controller chip, which is the current sense resistor pin. And the right pin of the controller chip goes to this inductor, which goes to the negative line that goes to the LED board. The power going to the LED board has a 2.2 microfarad 200 volt capacitor in parallel with it to smooth out the power to reduce flickering, and a 110 kilo ohm discharge resistor so the light turns off faster when you turn off the switch. And these go to the LED board's contacts. There's also a diode connected from the negative output of this converter to the positive output of the bridge rectifier for some reason. So this is what is inside of a Utilitech brand LED light bulb. It seems that this bulb wasn't designed to last that long because this is made of plastic and isn't made of metal, which could dissipate the heat a bit better. But anyways, make sure to subscribe for more videos.